be live right about now. If you can see me and if you can hear me, let me know with the good old S in the chat or something like that. I don't know, indicate somehow that things are working. If you can see me, and it's a little echoey, sorry about that. Listen folks, excuse me. Today's stream is very chill. I think I'm able to get it in 4K today, but yeah, today's stream is going to be super chill. All we're doing, let's see if I can get this a little closer. All we're doing is a little bit of test machining. I have some stock material here that I just cut out, just a little tiny block of, what is this, like 1/4 inch aluminum. Excuse me. I've been working, I got this CNC machine, this beautiful little Carbide 3D Nomad 883. Carbide was generous enough to send it to me in the fall, and so far I have used it to machine things, I think a total of 3 times. Each time I have broken bits or crashed the machine or done something wrong. And so my goal here today is just to get more practice. That's what the title says, CNC Machining Practice. And that's what it is. Yeah, my goal here is just to get more practice. It's okay to not be good at stuff, and I kind of like the idea of documenting that I'm not good at this right now, because I'd like to be, and maybe in like a year or two, I'll be better. And the thing that really drove it home to me was when I was messaging with Charlie, who is, I feel like the best way to introduce who Charlie is just, he's the dude I talk about the most on the rocketry stuff. But Charlie was like, listen man, you need to start machining more stuff. It's no harder than 3D printing or anything else you do. It's going to be the same thing though. Like, you're going to get started and you're going to be really bad at it. Like the first few prints that you do when you 3D print things or you design things or you solder stuff, any of the first projects you do, maybe the first 10 projects are all going to suck. And that's my goal here, is I just want to get through those first 10 or whatever it is so that I feel comfortable with the machine. And it's working so far. So that's why I'm here. If you have questions or if you just want to chat, I don't know. I'm just hoping to keep things real chill today, get real mad on the internet. And so trying to take that and do something good with it. Create something with it. I think I'd like to just take my mind off of the internet, and machining, chipping away metal is a great way to do that, I think. So hopefully the quality is good. What's the downlink speed? I'm pushing at 10,000 megabits a second. It should be a 4K stream. Let me refresh this and make sure it is, or just test if it is, I suppose. Here we go, 1440. It looks like we're stuck at 1440. We should be at 4K. And if you have questions about why I'm doing it, one way or another, the answer is probably just that I don't know any better. So part of this stream is just going to be people yelling at me for not doing things right, and that might be one of them. Yeah. There's nothing better than playing KSP and watching a Joey B stream. Well, thanks, Nicholas. All right. Oh, yeah, I got fiber internet. I got really, really frustrated at Comcast, and I had a somewhat spicy conversation with them on the phone, where when I tried to cancel, they were like, instead of canceling, do you want to pay us more money? And I was like, that's not how that works. Okay. I'm rambling a lot. Good thing this is the second channel. All right, so we're just going to secure this little piece, and before we do that, I wanted to mark the middle of it, because that's where my work coordinate system starts. And actually, the other thing I'd like to do is show you what we're doing. This is my computer, and interestingly enough, this is not the computer. This is an HDMI out on the machine, the computer that we're going to use to machine, because I don't trust OBS and the machining software on the same computer. Something about that seemed like a bad idea. So this is the part that we're going to make. Right here, it's a tiny little gear, and if I bring it into design, I can show you what the point of this gear is. I have this valve, oh boy. I have this valve right here that needs to be turned, and this gear is going to let us do that. And that's pretty much what this is. So there's a gear that goes onto the valve stem just like this. Each sort of held in place. I'm sort of testing out like different tolerances here. This is not going to be what I use to actuate this valve. If you're wondering what this valve does, the answer is, I can't tell you. Sorry. There are a number of people in here who know what it is. Let's see, here we go. Let me put this face camera here. Yeah, there are a number of people who know what this valve does and what it is. And there are some assumptions in here, but I'm going to tell you what, if you know what this is, no leaks, okay? No leaks. So this is the valve this is the gear that we're going to machine today. It's just this little thing. And why don't we walk through the toolpaths that we're going to use today. You'll also notice that I didn't totally contour the stem of the valve here, which is this piece that I have highlighted. I didn't properly contour that whole thing because I want I need the cutter to go beyond this corner. So I've just designed it so the cutter will go just a little bit beyond that corner, because otherwise the cutter that I'm using will chop into that. So we need to go a little past it. There may well be a better way to do this that doesn't involve designing it into the part. And once again, this is another opportunity where I can tell you I'm super new to all this stuff. So, Guigo says, I bet this valve controls the flow of some fluid. You are probably right about that. A lot of assumptions that it's for RCS, which are not bad assumptions, but not necessarily correct. All right, so this is the stock material that I have modeled. The stock material dimensions, we can look at the setup here. I'm going to change the size of my face. Yeah, all right, great. In the setup, right here, perfect, okay. It's a fixed size box, 35 by 35, depth of 6.8. And the 6.8 depth is accurate, but the 35 by 35 is inaccurate. This is actually like 50 something. Boy, I really need, where's my Sharpie? Hold on, everyone. Okay. What's the purpose of the corner reliefs? You mean on the gear? So the gear, that would just be the pressure angle is what the reliefs on the gear are. And then on the inner part of the gear, that is, what is it, like the inner fillet radius? And that's just due to the cutter diameter. Again, we're using a 1/16 inch end mill for most of this, with an 1/8 inch to face it off. And so our stock material here is on average about 45 millimeters. Yeah. About 45 millimeters, probably closer to 50, 45 by... It's almost 50 by 50. So I oversized the stock because the work holders that I want to use are pretty big. And so when we do these facing operations, we're just going to keep our lead in and lead out slow, and we're going to be cutting the whole time. All right. Yes, an end mill cannot do a sharp corner. So that person's got it. Carnival. Joe, will you continue the How to Land a Model Rocket series without the landing part? Nicolo, I'm not sure right now. I have a video. It's taking a long time. I do have a video on the simulation stuff coming out. The flight software, I sort of have the video scripted but haven't shot it, or rather I have like some of the software ready. But the landing model rockets stuff has really stagnated, just in the wake of trying to focus on other projects. Okay, so let's talk about this. This is our stock material and the part that we want to cut out of it. The work coordinate system is based off of the center. That's why we have the XYZ in the center there. And while I'm at it, I'm going to use this as an opportunity to make sure that we mark the center of this piece. So, center of 50 is 25, right there. Center of this is a little bit under 25. And it doesn't matter if we're exactly in the center. What really matters is that everyone agrees on where the center point is. That's the most important part. So I'm gonna do this right here and say, okay, that's where my center is. And that's pretty much it. Okay, great. So I've marked my part. And the model we're cutting out is the gear. We're cutting the gear out sort of upside down. The first thing that we're going to do is a facing operation. And so I've got my feeds and speeds up here. I'm pretty conservative based on the feeds and speeds that Carbide 3D recommends. The feed rate is 350 millimeters per minute. I'm sorry I'm doing this all in metric. It's just a hard habit to kick. The plunge feed rate, the ramp feed rate, all these lead in and lead out, I'm keeping these really nice and slow. This is a desktop machine, so we're trying to keep things pretty tame. If the most difficult operation today is the facing operation. We're doing it with an 1/8 inch flat end mill. The contour is just around here, so it's a little weird. We're not facing off the entire stock material. What else? We're doing multiple passes. The maximum step down is 0.23 millimeters. And then there's a finishing feed rate as well with the tiny finishing step down. I'm maybe gonna... You know what? That's fine. We can go fast if our step down's slow. Actually, whatever. There are a lot of things that are not optimized super well here. I'm not going to apologize for that. The step over is about the diameter of that, so we're taking full width of cut here. Frankly, maybe let's dial it back. Let's do like 0.3. Dialing it back will help reduce the load, so we're not just plowing into the material the whole time. Okay, so it's just going to recalculate that. Okay, and so this is our facing operation. Again, because it's a desktop machine, we're taking really tiny cuts. We're going really gentle on the machine. I'm going to use some cutting lubricant as well, and we're just going to face it down. If it's not going fast enough, or if things aren't looking great, look, we've got these really nice, easy ramp ins. If things aren't working super well, we'll go from there. Hey, Charlie, if things aren't working super well, or if it feels like we can push the tool a little harder, we'll go from there. But I'm fine with taking it easy for now. Okay, then we have a 2D pocketing operation that's going to clear out this inner part. And pretty similar stuff, except now we're switching over to the 16th inch flat end mill. I really need someone to just yell at me after we're done with the facing operation. I need some big help here. I can't forget to switch to the 16th inch end mill, and I know myself, this is a thing I could very easily just forget to do. So I can't forget to do that. Please help remind me if you're still here and watching. So we're just going to pocket out this little area in the center. We're doing multiple depths here, except we're taking it really easy on that 16-inch end mill. This is a tiny area, so it shouldn't take too long. Same thing with things not taking too long here is the boring operation. We're taking it really easy, just going through the center of the material. That's great. Oh, I just remembered. I need that bit of cork. Hold on, everybody. Okay, great. That's That's what I needed. Okay, so then we have a little boring operation, and then finally, once we've done all of the intricate stuff in the center, we can feel a little bit better about just moving to the outside and cutting everything out. And the way we're going to do that is a big old 2D contour operation. This one's going to take a little while to do. Again, it's a 16th inch flat end mill and multiple passes. And then this one, the cool thing is I've left tabs on here so that when the material gets cut out, we don't, like at the very end of the pass, we cut through almost all of it and we just leave these tiny little bits on the end of the part so that we can take a Dremel and just finish those off really easy. But that allows it to, I mean, things just don't get super chaotic when we, what am I trying to say here? Things don't get super chaotic when the part finishes and it has nothing to attach to. Our work holding is all on the side of the stock material, and since we're cutting out from the center, if we don't leave tabs on there, this thing is just going to start rattling around when there's nothing to attach to. So that worked pretty well before with a little wheel that I machined. I can go get that. Let me bring up the main camera here and I'll just show you what that looks like. This is the wheel that I machined before. You'll see the quality looks pretty great, and you can sort of tell where some of those tabs were. So see, like right there, that was one of the tabs. This was the same setup where we cut it out from the center of a piece of stock. That was a tab right there. So it's not perfect. It's certainly not perfect. That was a tab right there. And I think with something like if I had something like a rotary, like a belt sander would work pretty well, or like a burr grinder or something like that. The super glue method is a good alternative. Yeah, you could do super glue and then just grind it off or something. It also says encoder overloaded and poor connection. So I might try dialing this back just a little bit on the bit rate. Go down to like 8,000. That's probably plenty. The encoder is getting mad. All right. Well, oh, Christopher! Can we get a round of applause for Christopher? Christopher says, Joey, name each G-code file with the bit to use. That is an excellent solution. Thank you, Christopher. So let's do that. Why don't we go through just generating these G-code files. And we're only going to start with the facing operation. I'm just going to do one of these at a time. So I'm going to go into here, post process. We're going to start with 201 dash 1/8 inch because it's an 1/8 inch end mill. It's for a Carbide 3D machine. And that's it. We don't need to open the file afterward, and I'm going to save it. It's going to give me an option just in a second here. Not in Machining 1, but in Mech 2. That's where all of my files are going to go for today. So that's in this folder right here, Mech 2, and there's our first little file that we're going to use. I'm not going to generate anything else right now. Let's just start with the facing operation, and before that we have to actually get our work set up on the machine. All right. Yeah, that was a great idea, Christopher. So let's take a look here. This is our setup. Ugh. If I point it down, this is a little bit more clear here. Yeah, there we go. So I've got a piece of cork here, and I want to freely admit this is not really a great solution because cork has a lot of give to it. And plywood would be a better solution. Where are my scissors? My goodness. Well, where do you think the scissors went? let's take a look over here. Maybe they're in here? No. No. Bro, I have like 20 pairs of scissors. Where are... There they are. Okay. I found the scissors. Let me show you what's on my mind. Okay, this is a piece of cork, and what we're going to do is use this cork to go below the work on the machine. And what's going to end up happening here is when the machine goes just a little below the material, it's not going to cut into the metal work bed. It's going to cut into the cork, which is fine with me because cork is cheap. Now, I mentioned before this is not a good solution, and I want to just reiterate that. Super not a good solution because the cork is going to flex and bend, and that's just kind of what it is, right? It's just going to bend a bunch. So, here we go. Yeah, it's not a great solution. I'm not here to tell you this is the best way to do it, but it's what I've chosen to do. And you know what? I just want to look through this one more time. This facing operation, we can simulate it and get rid of the model so it's better. If we just show the stock material, the stock, I just want to make sure I don't crash the machine here. 35. Yeah, I don't think I will. I think it'll be okay. Painter's tape and super glue. Yeah. I do have a machine vise. The problem is like when you get those little tabs at the end with the machine vise, it's not, the material starts to flex. We're cutting so much of it out that it's just going to flex a bunch near the end of it. And I kind of would love to avoid that. We're also going to only clamp down kind of on the edges here. So it's going to be a little sketchy. Bear with your boy. I did cut the material bigger than I needed it though, which was my goal. Okay, that's not terrible. It's not good. It's not terrible. Joey, says Arsenio. And you will see, as I start to clamp down, it's going to sink into that cork. It worked last time, and boy, if there's one thing that's just a really good idea, it's the mentality of, well, it worked last time, so I'm sure it will work this time. That's always an appropriate attitude to have. And if you can't tell, I'm being facetious. F for the clamps. Low quality plywood. Yeah, so see, that's the thing. Plywood would be much better here. Plywood would definitely be better. However, cork is what I have, and I weirdly don't have any plywood. I build nothing out of wood. It's either plastic or metal. We're just gonna keep on clamping this down, but that feels really good. I can move the part. I can move the machine by grabbing onto the part. And that means we're all set here. And that's lateral force too, so we're good. Now, the first thing we're using is once again, what? It's an end mill. It's an 1/8 inch end mill. Yeah, and I looked at, it's not gonna drag the part anywhere. I was just curious about with the facing operation, I just want to make sure we don't crash the machine. And I don't think we will. I'm pretty sure. We'll see. I have a lot of extra bits. Last time I machined something, I broke 2 different bits pretty much right in a row because of who I am as a person. And so I bought a lot of extra bits just because I know who I am. How do you probe the stock? Nathan, what a great question. Why don't we find that out right now? And not necessarily find that out, but why don't I show you? So, first, we're going to load a tool in there. And actually, why don't we do it this way? I've got a couple of things up here. But I'm just going to put so Carbide Create is what you run the machine with. Maybe I'll put it down here. How about that? Okay. Oh, it's the Discord. Discord blowing up the phone. Okay, so first let's load a file. And I've got under Desktop, Mech-2, oh sorry, here we go. Desktop Mech-2, this is our first file to load, 2001 1/8 inch end mill. So I'm going to load that file. Uh-oh, Carbide Motion didn't like that, so I'm going to just change the dimensions a little bit. Is a treat. Oh boy, okay, hold on. This is kind of a mess. There it is, that's better. All right. So I can put it into jog mode. That's what we'll start out with. And we have no tool in there right now. The problem is we don't have, okay, yeah, let's load a tool in first before we begin the homing cycle. So this is our tool. This is a nice coated 1/8 inch end mill, 2 flute, and that's it. That's what we're using for this first operation. So I'm going to load it into the collet here. And that's plenty. Don't want to let it stick out too much. And then I'll use these 2 little clamps to tighten it down. 2 little wrenches to tighten it down. Sorry. There we go. So that's nice and tight in there. And now there's a little probe right here. So it's going to go find the probe when I run this homing cycle here. Let's do that right now. Right, so it's going to go over, it's going to find the probe, and then it's going to measure the length of the tool. Oh, it's going to ask us to load the tool, isn't it? Okay, yeah. Press button below to begin measuring the current tool length. So we already have one. Okay. So we measured the tool, which is great. And now we can jog it around. So I can change, let me just change the increment to fast, and I can show you by just clicking on different things. I can move it around, and now we're going to set the 0. So I mentioned earlier that we have our work coordinate system set up so that the center of the part is our 0. And so we're going to 0 out everything on the center right now. So here we go. Let me go a little higher. Yeah, there we go. Just trying to make it look nice. So I've got all these fast increments. We'll break it down a little bit. And really the right way to do this is to measure it with like a piece of paper or something. Like see if you can slide a piece of paper under there, and as soon as the paper doesn't budge anymore, that's how you know you're on top of the part. But because I have this nice close-up view, I can, and I can also just look at it and get a pretty good sense. It doesn't have to be crazy accurate. Plus, because I have the cork under, I have most of the tool paths set to go just a little bit under the part. And you know what I need to do here is add my pretty little face into here. That's nice. That's what everyone comes here to see. So weird. Why did I... Alright, so first let's center the X and the Y. And we need to be moving in smaller increments than that. So I'm moving in 0.1 millimeter increments. We can go finer if I need to, but... yeah, that's pretty good. And now we'll bring it down. Okay, and that's pretty much right on the top of the stock. So the last thing I want to do here is say set 0, and I've got all of these measurements for just where the stepper motors are, and I'll say 0 all, and now this is just 0. So if I say done, we can do a bunch of things, but we're pretty much good. If I do rapid position 2, let's just do the current offset plus 6 millimeters. So we'll move up, and I'm also going to just jog it up a little bit higher because these clamps are really high. Yeah. These clamps are very high up, and I really don't want to crash into them. I think that would be a bummer. I would be cry about that. Tell you what. So this is pretty much good. We have our work in there. I'm going to close the hood of the machine. Oh boy, there's like a little wrinkle there. Why don't we move it forward and maybe up a bit so there's not so much of a wrinkle. Okay. And I think we're ready to go. If no one minds, we'll probably just get going here. Milling away your clamp sounds like the thing you definitely want to do. As much as I would love to just smash an end mill right into my work holding setup, why don't we try to not do that? Here's my hearing protection. Oh, here it is. All right. Well, everyone, I want to thank you for joining the pleasant part of the stream because it's about to get not as pleasant. Oh, wow. Thank you, Aaron. That is very kind. I also missed another super chat. I'm sorry. Martian Lemon, thank you as well. Wow. That's more than a little appreciation. Thank you so much, Aaron. So let's do this. Let's give this a shot. Now there is a thing in front of the oh my gosh, cannot talk at all. There is a cover in front of the mill so that we don't get chips everywhere. However, it's a good idea to wear safety glasses anyway. I think there's no one who would disagree with that. And the last thing I want to get is a vacuum. I got my fancy little Dyson vacuum, and I think we're ready to go. So claws up, everyone. S in the chat. Let's hope we don't crash the machine. I have loaded the file. Let's just go to done. Load new file. This is the file we have loaded right now, 1/8 inch. We have an 1/8 inch end mill in. I think we're ready. 3, 2, 1. Wait, maybe I should make this a little smaller. Like, so just, I don't know where to put it. Maybe up top. Why don't we do it up top like that? That works. Okay, 3, 2, 1. Earmuffs on. Well, not yet. It does this every time. It's gonna ask us to change the tool. So here we go. Give it a sec. And there we go. Tool change required. So insert tool 3 to continue. So now it's gonna measure it again. And I am going to put my mouse over the pause button, just in case, as a treat. It is by no means a wonderful sound. Okay, so someone has a good suggestion of let's add some lubricant. I think that's a great idea. We're going to use plenty of that, and there's not too much harm that I can do by just adding some. Let me get a better mic mount though. You'll also notice that we're not taking anything off right now. And that's because the part is not evenly mounted on the workpiece. So doing a nice just operation like this helps level out the part. Okay, great. That's a little better. Needs a higher chip load, says someone. So the problem with the higher chip load is that it's not a strong machine. Nathan, there is no climb in this milling. can go faster. We can try increasing the feed rate if you want. Is that better or worse? So there is definitely like a lot of chatter here. Do I have any canned air? Yes, I do. Let me get some. I'm going to use the vacuum cleaner. Okay, hold on. Aluminum in the Dyson is fine. It'll survive. Okay, so we'll try to favor the compressed air from now on. And Nathan says Klein milling only. So I think that means we're just in reference to the spindle direction. We'll make some changes. I think I'm going to let this finish running. We're like 60% of the way through, so I'm going to let this finish. But we'll see how this does when we generate the next toolpath. We can sort of look at that. Maybe we're not moving fast enough. I've increased the feed rate a doesn't seem to help too much. I really think it has more to do with the connection now. This is my finishing pass. Yeah, so the finishing pass, the step down is really tiny. This is a very small depth of cut. We can look at what it is too. The depth of cut on the finishing is, let's look at this. Okay, so the depth of cut on the rough step down is 0.23 millimeters. The depth of cut on the finishing is 0.05 millimeters. So it sounds way better. I mean, it's just super quiet now. And I left this here so it's nice and shiny on top. It looks pretty good now, but not a lot of roughness. Okay, so that operation is done. That was nice and loud. You're making chips. Those only happen in Imperial. Alright, hold on. Let me move the machine around a little bit. Yeah, so this doesn't look too bad. It's nice and shiny because of that finishing pass. Actually, I probably don't need to clean anything up here. I just wanted to move this back so I can blow more of these chips off without them coming out toward me. There we go. Nice and aesthetically pleasing. Yes, so rest assured, I'm not sure how well the camera angle shows it, but it's a nice and clean part here. Very shiny on top. So now, why don't we take a look at the feeds and speeds for the next operation? Because it sounds like we just didn't do super well with this one. There was a lot of, I mean, definite chatter is one thing, and it seems to be in mostly one direction. So the next thing we have is a 2D pocket operation. It should be pretty short, but what I can do is I can reduce my, oh, and we need to change the tool. I'm doing that right now. I'm gonna change the tool right now because I will forget otherwise. I know myself, I'm gonna forget. So I will do that now. Okay, so our end mill has completed its journey today, and the coating still looks good, so we didn't like hurt it really, which is always a nice thing. So now we're going down to a 1/16 inch end mill. Super tiny boy. This guy. So that goes in here. We're gonna make sure it's pretty much all the way up there so that we reduce how much that little guy can shake around. And tighten it down. There will be no coming loose today. No bits coming loose. Now, I spec'd the part. I was careful about this. I spec'd the part so that we shouldn't crash into anything. If it looks like we're close, no, we shouldn't crash into anything. I hate how high these things are. I'm gonna pull it out just a little bit. I am just a tiny bit worried that the collet, or like the bit holder, is gonna hit something. So by just pulling it out a little tiny bit, I think we'll be okay. And we'll keep things nice and safe. And the bit will be fine. It'll live. All right, that's great. That works well. So let's take a look at the computer again. And I want to talk about what we've got going on here. So this is our second operation, the 2D pocketing. These are our feeds and speeds here. Again, it's a desktop machine. We can't clear mountains of material all at once. So we are just taking it real slow. I have broken 2 of these bits before because I go too aggressive. So you know what we're gonna do? The maximum roughing step down is gonna be, load up 1, 2. I'm gonna keep it real low, and then we have a tiny little finishing step down of 0.05, and I'm gonna do 0.04 just because I'm nervous. I really don't want to mess it up. So now when people talk about climb, can I get a little bit of chat assistance on climb and how to optimize for the direction that we're going in? That would be lovely. I would set it to climb milling only and set step over to 1/3 or 1/2 tool diameter for the next op. Right, so the step over, I had it here somewhere. Step over is 0.7. Hey Siri, what is 1/16 inch in millimeters?
Okay, I found this on the web.
Come on, man.
What is 1/16 inch in millimeters?
You have been around for like 10 years, Siri. You gotta be better than this. 1/16 inch in millimeters. 1.5. So 0.7 is half. That's great. So our step over is nice and tiny. We're just going to take it super, super easy. And the worst thing to worry about now is just heat. So we'll use a little lubricant. That'll help a little bit. Oh, the part feels very nice. It's extremely smooth. Climb is a better surface finish, but requires more machine stiffness. Oh, yeah. You can type inch after a number, and Fusion will convert it for you. All right. Why don't we just start here? Why don't we just start here and see how we do? I feel pretty good about this. I want to also simulate the operation. That always seems to help. And we're going to simulate it from the stock. Oh, what's the top of the pocketing? It should be model top. Yeah, it is, model top. So if I simulate from here, first we have the facing operation, which right, super fun. Everyone loves this. Okay, so then we finish this. Oh, there's our finishing. Okay, so, slow down. Yeah. So it's just like the step over is not at all aggressive. We're just clearing tiny bits of material at once. If anything, this is probably too tame. We doing leek soup? No leek soup, Arsenio. You can have any type of soup you want so long as it's not leek. Okay, it's just going to take forever to work. But so be it. And then after that, we have a boring operation. But let's focus on this first. So now on our 2D pocket, I'm going to say post-process. It's going to be 201 16th inch. Well, it's really 202. That's our second operation. And we have loaded the 16th inch, but just for posterity here, I'll load that in. So we're going to save it. And now in Carbide Motion, done. Let's load a new file. I have run the same. The way I broke 2 bits the last time I broke these little 16th inch end mills, the way I did it, or the way I got myself in trouble, is that I broke one because I took the cut too aggressively with the mill, and then I created a new file with a less aggressive feed and less aggressive feed rate, less aggressive depth of cut. And then I forgot to load in the new file, and I just ran the same one again and crashed it in the exact same place. Okay, so I've loaded the new file, 202 16th inch, and we don't need to center it again because we're keeping the same center. We don't have any reason to believe that we skipped any steps. And it asks us at the beginning of each one of these runs whether we want, or it tells us to load a new tool. So we're all set here. I'm going to put safety glasses on. Buffering quite heavily in the UK. Oh yeah, we were dropping some frames. Sorry, folks. That shouldn't be happening. It's probably just Wi-Fi. That's the error. Yeah, it looks like we dropped 442 frames. We'll keep an eye on it, but it would probably just be Wi-Fi errors, not the actual network, which seems to be really stable right now. Okay, well, let's see. Yeah, some intermittency. Looks like everyone caught a little glimpse of that. All right, ready? Everyone ready to start? Here we go. Where's my goggles? So it's going to measure the tool length, and then it's going to do it again, just as a treat, just for fun, you know? Okay, tool change required. And I'm going to keep my mouse over the pause button in case something doesn't work. Although hopefully we don't need that. Oh, we're good. Yeah, this is fine. Oh, I probably left in like a maximum, like a tool retract thing in here. Yeah, I bet I left in a, yeah, it's doing it again. I told it to keep tool down, maximum stay down distance. It's fine, it's whatever, it's not going to cost us much time. And our plunge isn't that bad, so this is fine. A little bit more lube, says people. Well, it didn't really get in there, did it? Chattering in the corners, yeah. That retract is kind of ridiculous. Bro, he be milling the Olive Garden with unlimited breadsticks. That's pretty good. I like the suggestion of taste the lube to proof that it's not olive oil. All right, we're gonna babysit the machine for the rest of this, so that finishing pass looks really nice. But there's just a lot of chips in there right now. Nice! All right. That's done. Two out of 4. Please do not. It will not be good eats. All right. Well, this looks pretty good. Nice and shiny at the bottom. Now, one thing that I do want to test, I'm just going to... Next thing is a boring operation, which is real easy to do. I would love to see how this feels on the valve, though. Here, I have the valve. This is the actual valve. Oh, wow. That is not at all a snug fit. So I fit this. It will turn, it will turn the valve. Yeah, it'll turn, but I I fit this is why you practice. I fit this with 3D printing tolerances. So I gave it like 0.1 millimeters on each side, right? I didn't give it, that's quite a lot. That's quite a big tolerance because I just assume that's just how I think, because I'm so used to printing in plastic where everything like oozes everywhere. So this gear isn't going to work. We're definitely going to finish it today, because this is about practice and making sure that I know what I'm doing, at least marginally. But we're definitely finishing it. I don't care. I think it's going to be really pretty. And maybe... especially because we know it's not going to turn out beautiful, I might add one nice, like, super clean finishing pass with like a ball end mill at the end. Lubricate it with fresh soil. Wow, there are a lot of great ideas in this chat. I won't accept the F's for the I won't accept F's for the I won't accept F's for the part not being within a good tolerance, though, because this is what it is. It's just practice. All right. What is on my shirt? It says None Pizza with Left John. It's a Vlogbrothers / internet thing. My None Pizza with Left Hank shirt arrives in the mail, I don't know, a week or two. The things I spend money on. Okay, so next is a boring operation. This one's super, super simple. I don't even think we need to check this, but we can. I got the pitch to be really tiny. I might even go just a little bit lower, just as a treat. Oh boy. Yeah. So it's just going to bore out a hole in the center there for a screw, even though that's not something we really need. Ooh. Nah, okay. Yeah, we've got a nice boring operation here. So let's go ahead, post-process, 203. Now, we're using the 16th inch for everything else. Excuse me, so I'm not going to label it. This is 2003. There we go. I'll just double check here. Yeah, 16th inch flat end mill. I'll load the new file, 003. There we go, and then we'll just run it. Pretty much it. I'm gonna add a little bit of lube in there. Everyone loves just a little bit of lube, and I use a lot. Okay, great. Things Joey B says. Here we go. Oh, it's gonna ask us to measure the tool again. Always love that. Make sure there's no chips on the bottom of it. And that's it. That was the whole thing. Just a tiny little boring op. And we almost certainly didn't need to do that as a separate task, but I did it as a treat. You can see. Oh boy, you can't see, can you? There's a tiny little hole in the center of it, but you can't see it. Okay, if I pick it up, you can see it. There it is. So now, this doesn't look at all like a gear, right? Like there's no part of this that resembles a gear. And now the last operation is a contour around the gear shape, and that's where it starts to really look like a gear. Damn, that was boring. Indeed it was. Well, this is going a lot more smoothly, which is the cue for it to stop going smoothly. Eric shared your post. Did I post? Oh, this is a memory. Never mind. Okay. So this is our operation. It is kind of long and kind of complicated. And once again, we're going to end up, you can actually see it here if I show you. Right here, see this little bump? We're going to leave tabs around the edge of the part so that it doesn't come chattering off once we cut out the bottom. But that's it. That's that. How are you going to anchor the part? Z, Chris, I think I may have just answered your question, but there's a delay on the stream. So just in case, There are little tabs at a bunch of points around the part, and if I click on the contour, you will probably see them under here. Yeah, here we go. See this little guy, and this little guy, and this one, and this one, and that one, and that one. So it's all, it's not held on at any like specific interval of gear teeth here, but it's just held on at a bunch of different points so that when the part, when we start cutting through the actual piece of metal, it's still held on at the end by a couple little tabs, and then I'll use a Dremel at the end to sort of file them down and file them off. I thought you were about to put a bolt through the boring operation you just did. That could work, but then I have to recenter it. Like, there's no way I could do it without recentering the part, which is not fine, because if I can keep everything in one operation without recentering the part, then I truly know that hole is in the center of the part, and that's super important. So this is our boring operation. It's going to take a long time. It is indeed going to be boring. Let's look at our step down again. 1.5. Let's go with like 1.2 to be safer. And I do have a finishing pass, although I guess it doesn't really matter because it's just against nothing. I want it to be. Do I want it to be left climb milling or right conventional milling? Can I get some thoughts on this? Everything so far has been left climb, except let's look at the facing operation, because I think it was both, right? Yeah, the facing operation is both. And the 2D contour, do I want it to be climb or conventional? Let's see what the chat says. That contour looks scary. It is scary. It is scary. It's going to get real dicey with the chip clearing near the end. Climb is what sounded like the best. The other operations that I was doing, like the bore, that doesn't have an option. How about the pocket? The pocketing sounded pretty good, and that was climb. Climb is sounding better than conventional. More lube is always the answer. I would conventionally climb it. Thank you, DJ Rob William. Very much appreciated. Please ship the TVC to Canada. Jason, I wish I could. But I don't feel comfortable doing it. There are some laws surrounding that, the export of that stuff, that I think it would almost certainly be fine, but I'm not willing to risk it for the consequences. All right, let's do it, right? Let's do it. So here's our operation. I don't know why it's not showing it, but this is our operation. Here we go. Can you show me the toolpath, please? No? I guess not. Oh, it's generating. Okay, great. It might take a while to do that because there's a lot of moves on this. It took a while even on the Mac Pro. Sometimes you just need more lubrication. Yeah, so someone suggested adaptive clearing. I thought about that too, but I don't need to clear out anything except for the edges here. So I think unless I was really, really concerned about the surface finish on the teeth, which is valid, I think in the future maybe that's a good idea. Even with chip clearing issues, I think it'll be fine. Thanks, Jared. Do you have money burning a hole in your pocket? Well, worry no more. You can get BPS merch. That's true. Okay. Oh my gosh, only 30% generated. It takes forever to do this. It is, how you say, one big operation. How did you select a gear thickness? Christopher, good question. I selected it based on my stock material that I wanted to use, which was a 1/4 inch stock. And so I just made it a little bit thinner than 1/4 inch stock. And then, more importantly than that, is I considered the end mill that I was going to use. So this is the mill, right here, this little guy. And this is about 6 millimeters in height before it begins to taper outward. Oh, I'm sorry, I didn't show the camera. Here we go. This is the mill. It's a little 16th inch end mill, and the biggest consideration for the gear height is that the distance from the taper of this mill to the end of this mill is about 6 millimeters. So if I want to use this tool, I can't do anything deeper than 6 millimeters without starting to chip away at it at the top. And so that was my biggest consideration here. Or that's like what went into it the most. There's a lot of... Someone found an old video. Someone found a great old video in the Discord. Anchovy Knowledge says, "Hi Joe, just want to let you know that I have started work on a flight computer that uses to use in a TVC rocket. Thanks for inspiring me to learn more." That's awesome, Anchovy Knowledge. Well, let me thank Anchovy Knowledge back. If anyone follows the BPS social pages, you'll know that I'm slowly working on, and actually Parker is more than I am, but I'm working on we are working on an air-launched rocket, a model of the Virgin Orbit Launcher 1. Oh, our toolpath generated. Nice. The Virgin Orbit Launcher 1. So it's going to be dropped from a plane. We think it might end up being a helicopter. I'm really letting the pilot decide what he thinks is best. We already have a pilot picked out for it. But that is all Anchovy Knowledge who said that they wanted to see something like that. Oh, wow, this is going to take a long time. Whatever. We'll go 205, even though I think it really should be 204. It doesn't matter what the number is. It's a 16th inch end mill. Right? Yes. So now I'm going to load a new file. Okay, great. New file loaded. We don't have to zero it. Oh no, it forces me to measure the tool length. Woo! Woo! Okay. Run. Oh, come on. Run. Here we go. Ready, everyone? Safety glasses on. Measure your tool, please. Is this pleasant to watch for everyone? I should put my hand over the stop key. Okay. I don't like that chatter. And I don't like how slowly we're moving. and I want to try the other direction. So I want to change like a lot. We're early on. It didn't sound good. Okay, lube. I know. The lube, right. But I want to try the conventional. And I want to go a little harder on this step down. And maybe a little faster as a treat. Now it has to generate again. Yes, okay. We would. Thank you, everyone. We will do more lube. Here it is. Lube for everyone. 2 nice dollops of it. Change every variable so you know what's up. That way you can really narrow in on what it is. The best way to do it is by changing every variable. I'm texting my friend. Sorry, everyone. Sorry for the silence. Parts can have a little lube as a treat. Oh my gosh, this could not possibly generate slower. What's your lube rate? 50 lubes per cubic inch. This really should be 2D adaptive. The problem is I don't need it to be adaptive. I don't need to clear away that material. I just need to cut out the gear. Like, I don't need to clear away a ton of material. Hey, this is a cool question. Michael Wilson says, this is complete... Oh, sorry, I should switch to this. This is completely unrelated, but I was wondering if you had any tips on finding the relationship of jet vanes and side force due to your work with Sprite. Michael! Yes, I do! I have some advice for you. Well, I don't know. It's not necessarily advice, but it's what I did. I took my test stand. I made a video about it in the fall. I have this test stand that's basically not really a test stand. It's just a bunch of pieces of 80-20. Or 20-20, I guess. Okay, we're going to do 206. I took my test stand and I put an extra load cell on the side of it, and I put it right at the attachment point. Boy, this is difficult to describe. There are some tweets about it if you're really curious what it looks like. Someone may be able to find it and put a link in the chat. There are some tweets about it from probably January. What I did is I ran actuation tests of the jet vanes while the fan was running at a nominal hover throttle. So for me, that was like 85%. Wasn't super efficient, but... and then I ran deflection tests of 1 degree, 3 degrees, 6 degrees, 9 degrees, 12 degrees. I just did increments of 3. And then because it's not a linear relationship, you use those forces, you put them all on a big old spreadsheet, and and then when you're doing those actuations, you're pushing against that load cell so you can measure the force. And the really important thing is that you measure the force exactly at the point that the TVC you measure it exactly at the point at which the servo actuates. As long as the servo is rigidly mounted, you measure it at the point at which the servo actuates, the same height. I put it upside down to do this too. And so then you just push the craft to the side against the load cell, and you can measure the force with the whole craft set up, just mounted upside down. And that's how I did it. So then when you have all of that data, I brought it into Google Sheets. And Google Sheets has a bunch of tools for plotting information, but if you plot the force and the actuation angle, you can get a big old lookup table and then generate a line of best fit. It's going to be like a third order polynomial or something because it's super nonlinear. And then you use that polynomial in the flight software when you say, I want to generate this torque. You run it through like the moment arm and the mass of the vehicle, and then when you find out, like the way you find out what angle to put in your thrust vector control servos or your jet vane servos, the way to find that angle is you run it through the polynomial of how much force do you want, and that polynomial will like work backwards to spit out what TVC angle to give you. It's pretty cool. It takes a little while to set up, but it's pretty cool. All right, I generated it. I made it 2006, so we're gonna load the new file. There we go. I hope that was a worthwhile explanation. Okay, there's a lot of lube on there. Let's run it again. Here we go. Use Excel. Yeah, you could do it in Excel too. There's no discrimination about what tool to use on something like that. Use whatever you'd like. Oh, Jeffrey Gill! What up? Everyone say hi, Jeffrey. Jeffrey Gill is my buddy, and he needs a aluminum label made for his truck, and so later this month probably I'm gonna. Jared thinks I should stop saying lube. I'm gonna machine a nice like 8-inch decal / label for the side of his truck because I need more practice and he needs a label. Anyway, that's it. Okay, insert the tool. I did. It's ready. I'm gonna hold my thing over the pause button. Gonna measure the tool. This doesn't sound that bad. This sounds pretty good. I mean, it doesn't sound good, it just doesn't sound bad. I do think we can be going faster though. I'm going to increase the feed rate. Alright. It's looking good. It's a little chattery. Yeah, Arsenio says he thinks it's pretty close to the sweet spot, and I think he's right. I mean, it's not... You can hear it gets mad. It doesn't love this operation, but it'll do it. Let's give it some lube! Let's lube it up! Lube it up, boys. Okay, I increased the feed rate a little bit. We're at almost like 200% of the feed rate that I set. Parker engines, I think this is a good idea. Probably needs smoothing and fusion. You can see where the feed rate drops way down as there's too many really tiny steps. So you're right, I do not have smoothing on here. Yeah, I do not have smoothing on. Man, it is not a happy sound. Should I stop it and try something else? Okay, everyone wants me to let it run, so we're just going to let it run then. Also, Max, I saw your comment. Joe, if you're running Carbide, which I am, you either need to use lube or not. You can't do it intermittently or else the Carbide will crack and shatter due to the drastic temperature changes. Max, that's a great thing that I did not know, so thank you very much. So I'm going to just try to keep lube on it from now on. I might do some chip evacuation stuff, but I'll just add a little bit of lube after. Nathan says, Joe, you've convinced me not to buy a CNC mill that doesn't have a coolant system. The good news is I think I can pretty easily add some at least like air cooling to this. Almost certainly not mist cooling, but air cooling could work. Someone asks if the aluminum is welding itself to the bit. From what I can see, it's not. There's just a lot of chips and a lot of lube. All right, we'll clear some of the chips out and we'll use a little bit more lube. Need a camera rig mounted to the spindle. Alright, You were promised lube, and there it is. The good news here is that the edges look pretty good. I mean, you can hear there's chatter, but the edges look okay. Okay, Max says no more oil. Like Beaches and Peregrine were saying, lube now would clog the channels with chips. Okay, so no more oil after this. The other thing is there's oil that, I mean, but the people who know what they're doing do not need to hear this, but it does seem like there's plenty of oil here. There's plenty of oil here that you, like, can't see. So even when there's, you know, a bunch of chip evacuation that happens, there's still a good amount of lube on there. Oh, this old Tony is awesome. That's a good recommendation. His videos are consistently so creative. I can't speak to how good he is as a machinist. He seems pretty good. I mean, he's way better than me, but his videos are consistently some of the most creative I've seen on YouTube. I really love his style. I mean, he can cut steel with his fingertips. What's not to like? Leek soup is off the menu, but chip soup is in. Aaron is correct. Air and vacuum attachment project coming up for me. Probably just air, but that's going to need to happen. Let me ask everyone a question, and I want to preface it by saying there are no dumb questions. I'm just learning. In order to help manage this thermal situation, how truly terrible of an idea is it if I were to put a small piece of ice onto the center of this part? How truly terrible would that be? I assume pretty bad, but I want to hear why. That got a lot of response. Yeah, no. It's a no. It's gonna be a no. That is a horrible, horrible idea. No, alright, I won't do it. I won't do it. If I ever become someone, Michael Ding would like a carbonated milk coolant. And I'll tell you what, Michael, if I ever become like a billionaire, it seems like I should have, at that point, the resources to hire someone to help me build a carbonated milk coolant and to solve all of the associated problems with a thing like that. I'll tell you, I'll commit to that. Jake asks, did it cost a lot to build rockets when you first started? Yeah, it did, but more than the rockets, it was mostly the tools, because I had no tools getting started. So buying a toolbox and all the tools that I thought I would need, some of which I was right about and some of which I've literally never used. Nice little cleanup there. It was the tools that were expensive, and then after I bought the tools, so in the first month, I don't know, like $500 to $800 worth of tools and a workbench and stuff like that. Maybe not that much. You could probably do it for $200 or $300, but then each rocket that I smashed got expensive, and that was more in terms of time, really, than money. But you could definitely do it cheaper today. I mean, all of the folks who have accomplished... I am far from the only person who's been able to fly a thrust-vectored model rocket. You can absolutely do it, and I think you can absolutely do it for, you know, a not terrible price range, even if you're just getting started, as long as you're, I think, patient. What's a tool I've never used? Well, let's play that game. I'm right next to my toolbox. I bought these sheet metal trimmers, and I think I might have used them once or twice. So it doesn't count as never used. Alright, I found one that I've never used. Raise your hand in the chat if you know about what I did with Cat5 cable. Raise your hand in the chat. If you know what I did with Cat5 cable, then this tool will be familiar to you, and I promise I have never used it. For a while, for a very short, brief while, I routed a bunch of things in my rocket through Cat5 cable. Here it is. Alright, I'm going to use a little bit more of it. Just a tiny bit. So, I routed things through my rocket with Cat5 cable, like this. And don't do this. It's a bad idea for about 1,000 reasons. And Yeah, I mean, just don't do it at all. Like, truly, please, please, please don't do it. But when I bought all of these things, and I thought, and I had the bright idea to route everything through this Cat5 cable, I also bought a Cat5 Crimper. And so it can crimp either, you can maybe see it here, 6-pin or 8-pin Ethernet cable. And so I have this crimper that I never ever used because I never actually I did pull apart the cable once, but I never crimped the cables onto a different Cat5 connection. Anyway, the point is that this is a tool that I bought that had to be like $20 or $30 that I never used. Alright, sorry, we're texting. What? Yeah. Why don't you use the Cat5 cable for its intended purpose? It would probably help stream quality. You know, it probably would, but I've got all of my USB-C ports used up, and I'm not trying to fin up right now. That's not the whole story, Joe? Jared, what is the whole story? I mean, there's plenty of memes to be had about the Cat5 cable, so which meme are you referring to? Well, the gear is looking great. There's definitely chatter. Oh no! I missed the NAS deadline. That's not good. Jared says, lube your GSE and twisted I2C. Yeah, so the ultimate end of the Cat5 cable, which should, I will admit, it should have come sooner than it did, but the ultimate end is that I used this cable and I would clip off the little attachment point, the point where it attaches to the connector here. I would clip that off so it could easily go in and out without, clipping in and clipping out. And then I use that as a ground support equipment connection. I'll show you. So here it is. This is where it says LP or Launchpad on the flight computer. This is the flight computer. And so here we go. You'd plug in the Launchpad, and then when it was time to launch, so long as you didn't have that clip on there, you just pull it out, right? It's terrible. Look, I'm not here to tell you it's good. I'm just here to be honest. That's what I did. That bit me in the ye old buttocks really good when one time I launched when it was really cold, and you know what happens to plastics when it's cold? They change their shape, and the plastic got stuck in the rocket, and when the GSE tried to yank it out, it also yanked the rocket, tipping it over, and also lighting the motor, which was not great. Thank you for the reminders to evacuate the chips, by the way. Your start as a machinist is much smoother than mine. Well, Michael, my start as a machinist is not what you're seeing right now. My start was in the fall when I machined those brackets for the launch pad, and that was a lot more rough than this. It wasn't that much better, but... No, sorry. This isn't that much better, but the first attempt was much worse. Joe, what are your thoughts on using CAN for rockets? I'm most likely going to be implementing a CAN bus for my next generation. Do you have any experience with it? Maxwell, yeah. So the Ava board... Hold on, let me get it. So, yeah, the Ava board, this is the one that burned real good. You probably can't see it. Right there, there's a little H and a little L. Actually, you definitely can see it. There's an H and an L right by that LED. And the H and the L are CAN high and CAN low. So there's a CAN bus on Ava. And Ava connects to a different computer that has yet to be designed. It's a controller of something on a project somewhere, sometime. But it does use CAN bus. I think CAN is like the... I had a good tweet about it recently, I don't know, like a couple months ago, that like CAN is like the hot girl down the street or something. I don't know. It sounds bad out of context. But I like CAN bus. I think it's super robust. I think it's great. I mean, as exemplified by it being used all over the automotive industry, CAN bus is a pretty strong contender. It's like I2C, but way better. Ian knows who Ava's sister is. Yes, Ava communicates with a sister board, and I can't tell you the name of it yet, but the patrons know. All right, let's clear some chips. Alright. We're getting there. Someone asks, is that fixtured on a piece of cork? That's probably contributing to the chatter and noise. Yeah, it might be. Honestly, I would expect the cork to deaden some of that, but I'm far from the expert on this, so I could be wrong. My thoughts were to use a CAN bus connecting the upper and lower stages using copper pads that connect between the two bodies to control the lower thrust vector control with one board. Max, I think it really depends on how you set up your connection between those two things. Like, the most shoddy part of that is not the CAN bus itself, but it depends how you set up the physical connection between those two things. I don't know. I mean, I know CAN is pretty fault tolerant, but yeah, I think that would be the limiting factor. We use CAN for robots in the first robotics competition, and CAN can be a real issue sometimes. If CAN fails somewhere towards the beginning of the loop, it can break the entire bus. Well, so I guess it's like the good and bad part of the bus is that any device can talk to anything else, and there's not like, I don't know. There are good and bad parts. I should just let you know I haven't done anything with the CAN bus yet. I'm just going off of what I've heard. Joe, when's the 24-hour stream going to be? So Nathan, is that my punishment for not doing the NAS? Is the 24-hour stream the punishment for the NAS? Are fiber optics for data used in rockets these days? Aaron, I don't think so. The speed of light or the speed of electricity through copper is probably, I think that's mostly sufficient for most vehicles. Jared, I don't believe there are masters and slaves on CAN bus. I believe it's just a total priority system in terms of, again, I'm not the expert, but I think it's a priority system, and different devices get to talk based on their priority in reference to other devices. Alright, it's really looking like a gear now. Should I get the macro lens? Let's get the macro lens. Let's get real close. Stand by. Oh, very pretty. Okay, sorry this is like so terrible right now. Hold on. Yeah, there's real chatter there. You can see it. Is that a Nun Pizza Left John shirt? Joshua, it is! And I have my Nun Pizza Left Hank shirt in the mail. Don't your neighbors say something about the noise? I am fortunate to have no neighbors on either side of my walls. So, fortunately, they do not say anything about it. Maxwell Haywood says, pleasure talking to Joe and you guys. Gonna head out now. Hoping to talk to you more about the technical conversation in the future. If you want any advice machining from a motorsports guy, let you know. Thanks, Maxwell. Thanks for joining. And thank you for the advice. check this out. I've got flux on my computer, and I'm just taking an HDMI out of the machining computer, so I'm going to turn flux off. And there we go. Now it's a better color. Aren't you glad you have your own place? Chris, yes I am. At some point in my life, I will probably share a house with more people than just one. And I love that not being the case right now. Got that True Tone. Well, yeah, True Tone, but True Tone before Apple implemented it, so it was just Flux. Alright, time for more angles. Oh, do I have a laser thermometer? Yes, I do. Why don't we get that? That was a great idea. Okay, so the hottest thing by far is the spindle itself, the flywheel that goes around the spindle, and that was 40 C. This is all in Celsius. Everything else was hovering around 30 or 35. I mean, even though it's shiny and it probably is not perfect, the metal is cool to the touch. Okay, no. I didn't mean to call it, Michael. Good call. The call it was probably about 35 C. The spindle was hotter, and that probably has more to do. Well, it's not directly connected to the motor, so I'm not sure what the deal with the. It's like the casing around the spindle. It's probably a bearing, is what it is. Alright, we're a little over halfway done. Very slow operation, and I think someone was right. It probably is just the smoothing, or the lack of smoothing, and we just can't walk through all of the steps fast enough. This is great. This is why we practice. Still going. If your bearing is 40C, I would be slightly worried. Yeah. The bearing is hot enough that, like, you can keep your finger on it. You don't really want to keep your finger on it, but you can, and it would be fine. What are you making, says Velocity Launch Systems. I am making a gear, and it's a gear that will probably be used in nothing, but it's a test gear because I need to hone in my machining skills and get better at it. So this gear is just an exercise for me, and it's not going to fly on anything, it's not going to do a whole lot, it's just I need more practice machining, and so far it's going well. I have broken a bit or crashed the machine every time I've done machining until today. So things are going well. I'm improving. I haven't crashed it yet. So we'll see. Is there any chance that more lube is a good idea? Or will it just gum things up? No more lube, says Peregrine. It'll just get stuck down there. Don't bother with lube at this point. Keep saying lube, but don't add more. That feels like a happy medium between everyone. Is just keep saying lube, but don't add any more. So lube, 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 lube. Alright, 63%. What do we do when we hit 69%? What do we do? Casey Schmidt says, isopropyl alcohol works good with aluminum if you don't have specific aluminum lube. The cutting fluid I have it's Tap Magic, and it's rated for aluminum, nickel, titanium, stainless. So I think it should be fine. Aaron says, question, if money was no object, what tool would you want? Aaron, I would want a... honestly, I'd want to hire another engineer. Parker is on the BPS payroll right now as an intern, and I think at this point having multiple people to help me pursue multiple projects at once has been great. He's been doing an awesome job, and it's been great to have days where it's like, even if I spend the day totally troubleshooting something really tiny, I know that's not everything that got done because Parker was working too. So I think I would just hire another engineer if money was no object. And if money was no object, I'd hire a really good one. Or at least a really expensive one. Alright, people want lube at 69%, but I don't think I need that. Maybe I can yell lube at 69%. 5-axis CNC. That would be fun, but I don't know if I have space for it, or if I have the knowledge to operate it. That's hence another reason that a good engineer is a good idea. Oh, maybe I'd get like a really nice fiber optic IMU. Jared, actually, yeah, Jared should be on the payroll as well as the BPS merch manager. Jared gets free merch as it is, but that is still probably not payment enough for the work that he's done. Alright, we're almost there, 67%. What do? I need consensus. Peregrine wants me to yell lube slowly. Alright. 68! It's 68%! You can see it in the top left of your screen. I think I'm just gonna yell lube. That seems to be what everyone wants. I'm gonna, I'll tell you what, folks. I love you all so much. It brings me such joy that I get to do this and somehow pay my bills. So I will give you the loudest yell of lubricant that I can possibly do. I'm gonna clear these chips. Here it goes. Lube! There it is. It's the price I pay. Thank you for joining, everybody. Alright, still going well. Joey B delivers. Now whisper it into the mic. I'm Joey B. I'm not going to whisper lube into the mic until we hit... We need a more special occasion for that. Alright, we're getting there, folks. We're almost 3/4 of the way through. How about a new angle? It's a lot of machining. if people enjoy this, and I can't really imagine that they do, but if people enjoy this, I'll do more of them. These are easy streams to run, and it's a pretty boring thing to just watch, but we get to hang out, which is cool. And it would be fun to do, you know, a project like this where we make a little like fidget spinner or like a fidget toy for my desk or something like that, where we could do 2 of these little gears at different ratios or something like that. Can I carbonate mustard? I think that would be difficult. Just based on like the thickness, like the viscosity of the mustard. We could absolutely be cutting more aggressively with this, but we're most of the way through the tool path. We'll just let it run out. Alright, people are into it. How about 3D printing a vacuum attachment to clear the chips? Jake, I love it. I'm into it. Live it. Love it. Learn it. Never let it go. I think that's a great idea. I would probably not do a vacuum. I guess I could do it. I don't own a shop vac, but that's probably a good purchase to make. But maybe just some compressed air. Yeah, maybe some compressed air would be good. Oh man, you know what would be cool is to just add into the G code, like, you know, where you'd usually put like a 4th axis or something like that. You could just add a servo-actuated compressed air canister, right? You could do that, and then just route the little tubing right down near where the spindle is, and you could time how often to spray compressed air. Do I make money from YouTube? Yes, I do. I do indeed. It's not much and it's not reliable, but it definitely helps. Yeah, it helps. I'll tell you this. The nice cameras that I used to shoot the rocket launches were funded with, and this is a fluke, this is not how videos normally do, but the carbonated milk video did very well at 1.5 million views, and I don't know why, but that very bizarrely funded the tracking camera, the super nice camera that I shoot with now. Alright, almost 80%. Oh boy. Matt Gray has a channel where he puts random stuff in a soft serve machine. There's an absence of such a channel for carbonating things. Do I have a day job? I do not. I am also grateful for that. Not only because I just get to do what I really enjoy doing, for the most part. I mean, everyone has stuff that they don't like doing, but also because I get to work from home, and I get to do it comfortably because I always work from home. So when there's a pandemic, thankfully, I'm able to keep doing most of what I do, and even when I do have to go outside, I'm usually alone or with one other person in the middle of the field. Arsenio says, haha, money machine go burr. Thanks for the super chat, Arsenio. Alright, you know how you can tell that we're getting down to it? Let's get back to the milling here. Here's how you can tell. You can tell because you can see the taper on the mill. You can see the taper on the mill is getting really close to the part. And I spec'd it specifically so that we wouldn't hit that taper. So we should still be good, but we can't be hitting that taper. So we know we're close. Carbonated lube. Alright, almost 84%. We're getting there. What's the tolerance you're aiming for? Well, that ship has already sailed. I'm sorry to say, Fuzz the Awesome. I'm sorry to say. This is strangely therapeutic. So the tolerance, this is a part that is supposed to fit onto a valve stem, or I guess it's not the stem, but maybe it is the stem. It's the valve actuation point, and I spec'd it. This is all practice, right? You can see it in the title. It's CNC Machining Practice. So I've made 3 metal parts in my life so far. This is the 4th now, and you know, tolerances are not my strong suit with that because I just haven't done it a whole lot. So I over-spec'd. I made this too big. This gear here is just going to have way too much backlash on this valve. But it's practice. So I'll do another version. Maybe I'll stream it. I don't know. But I'll do another version at some point where we try to dial in the tolerance a little bit more. And maybe before I do that, I can do just a little thing into some stock material where we test what is the tightest possible tolerance I can get before this valve actuation point no longer fits into the metal. I think that would be a great exercise, is just copy and paste a bunch of these, dial back the tolerance by 0.1 millimeters each time, or 0.01, whatever it takes, and then we find out what is what's the tolerance we can do on that. Hey Joey B, what's the soldering iron you use? I'm looking at getting a new one. I use one of these really cheap Chinese soldering irons. I think it's like $50. I covered it up in tape, so I don't know what the brand name is, but they're all about the same. Honestly, you know who I would ask for that, or you know who I would look to for what's a good soldering iron, and someone who can tell you what a good soldering iron is Louis Rossman. He's on YouTube. He has a great channel. He's a really smart guy. I really like his videos too, but Louis Rossman has, I think, a couple good videos on what soldering iron he uses. Chris Silva says you should set up a time-lapse camera and lighting for the CNC to get more footage. You know what? I think that's a great idea, and what I'd really like to do is do what Winston Moy does. Winston Moy has an awesome machining channel, and he works for Carbide a lot, but I would like to set up little LED strips on the side. I think that would be great. Also, Nathan says, are you going to stream machining some parts for blank? And Nathan, I believe I know what blank is, and the answer, I think, is yes, because so far everyone has been very, very good about not spilling any of the tasty, wonderful leek soup. I'm really surprised about that. Thank you all for cooperating with the no leaks policy. Alright, almost 90%. What type of angle would y'all prefer? Should I go like all the way top down so we can see when we cut through? I think we should. I think we should do top down. I think we're cutting through! We're cutting through! That's cork! So we also have tabs on here, so the part should not come off. I'm a little concerned that we've reached the cork and we're not at like 98%, but I think it should be okay. We're gonna let it run. I have confidence, and I only... Ah! Uh-oh! Okay. Well, I spoke too soon. Uh-oh, did I break the bit? I don't know. I'm not sure if I broke the bit. We're definitely out. Okay. Okay. Well, so I said this earlier, but I spoke too soon. I said so far today we haven't broken a bit, and lo and behold, I did. I did indeed break a bit. So that's fine. It's still practice. I'm not mad. I'm just disappointed. No, I'm not. I'm not even mad or disappointed. It looks like it finished. From this angle, it's hard to tell if I broke the bit. I kind of think I didn't, but it doesn't look amazing. Should we check it out? Should we see how it looks? It looks like the defining thing is that the tabs I made were too small, and thus they did not hold the workpiece. So I'm going to reconnect to the cutter. Okay, and we're going to do a little jog. It's going to pull the tool out, and hopefully we should be good. Oh, we are okay. We're in the clear. Wow. we got... Okay, hold on. Stand by. Right. So, there's our workpiece. Here's what we cut out. This is the gear. There's a lot of chatter on the edges. And can you see... You can't really see where the tabs were from that angle. Where were they? Okay, well you can see where the tool got stuck. That much is clear. Yeah, you know what? I think okay, yeah, I think I do see the tab thing. I think what happened is that yeah, I think what happened... Stand by. Yeah, I think what happened is that I made the tabs too small, and I went far enough through the workpiece because of bad leveling on the top of the stock that the tabs, which were made to be like right at the bottom and like, you know, a 0.5 millimeter tall, we just got the tolerance off. I think that's what happened. But this is the part that it's supposed to hook into. You can see it there. It's supposed to go on there, and then the screw goes through. So it does work. And oh, jeez. Okay. Well, I can't do it because it's not chamfered, and it's actually, the edges are very sharp. It hurts quite a bit to try and turn it. And this valve, I'll tell you, it's not rated to like 2 psi. It's rated to higher than that by an amount. So yeah, but you can tell here. Okay, hold on. Let's just do this over here. You can tell there's a decent amount of slop in this. This is not turning the valve at all, so that's, I don't know, that's like a solid 4 degrees or something like that. But this is great. So what I'd like to do is machine a part next time, whenever I do this next, where we just focus on this center section of the gear. And so we'll take a piece of stock material, I'll mill a bunch of these sections through it, and see which one fits best. But overall, I'm pretty happy with how this went. I learned that I need to just be a little bit more generous with the tabs that I give. It's really easy to cut through them at the end, so I should have just done that from the start. Should have made them, you know, like millimeter and a half. Those are easy to cut through and sand down. But this is great. Thank you all so much for joining. I hope you enjoyed this. Can I just make this bigger? Hold on. Video capture device. And here we go. I'll just make my face big so we can talk like this. Yeah, thank you all for joining. This was fun. I'm glad I did it. Charlie has hit me up almost every day to say, what are you machining today? And so far it's going well. I've made 2 different parts. One of them is here somewhere. Here it is. This one looks a lot nicer than the one thing that I just made. This is a nice, like really well polished off flywheel, which is pretty cool. Oh, this is forced to a bad setting. Does it look good on the stream? Copy video URL. It feels like it doesn't look good on the stream, does it? Hold on. I'm about to find out if the stream looked the whole time. Like, how many frames am I dropping? It looks smooth here, but I can't tell. Okay, yeah, encoding overloaded, so maybe looks nice. Who knows, man? Yeah, choppy stream looks passable. Okay, well, I'll try to fix this for next time. I just set it up super quick. Yeah, passable is not really what we're going for. So, anyway, thanks for joining me. This was super fun. I love the surface finish on this. Let's do another one. Let's do another one pretty soon. Yeah, choppy. Okay. Sorry, folks. I will be back next time with a better quality stream. And I think that's about it. This stuff is super fun. I really like doing it. So, can you tell here? Like, I want to know if you can tell where... Yeah, you can't even tell where the tabs were supposed to be. Alright. It doesn't matter. That'll be fine. Thanks, everyone, for joining. My name's Joe Barnard. I'll talk to you soon. This isn't the BPS channel, so I can't say the sky's blue, wind's low thing. I'll talk to you soon. Goodbye, everyone.